So I'm going to take the integral of this thing. We're going to start by taking the integral. If you guys don't mind, my notes are written the other way, and so I don't like trying to swap all these in my head as I'm writing these notes. I can go ahead and put it in the way I had it written. Dx dy is what I did. Not that it makes a big difference. So I'm going to take the integral of this thing. Where do we start?
U sub.
You do U sub. What am I going to U sub?
X squared plus plus y squared. 2x dx. So if you substitute x dx half u.
Now, this is looking glorious. Except for one thorn in our sides that's going to make this not work. No, that's going to turn out pretty. So stop writing for a second. This is what's going to happen if I do this. U square root x y dx 2x. Oh, it's so pretty. Integrated from where to where?
U of 2. Oh, like,
You gotta change your bounds
Yeah,
function.
yeah,
turn it
just
to-
put-
When I plug 0 into here, I get
0.
Y squared.
Oh, y squared. Oh, no.
and then when I plug in 1, I get 1 plus y squared. Now, we can do this, right? You would just integrate as normal and plug in this weird y squared to 1 plus y squared function at the end as your values. Like, really, you would just do this all the same. But I'm going to suggest there's a better way to do this. I'm going to try and use the u substitution without actually writing out the u substitution. It's going to be like I'm going to try and use the same thing that we did on the last problem. I claim that this is one that we can sort of visualize.
You can just convert back from u, right? At the end.
Yep.
Oh, you
Now-
still.
Again, looking ahead, so if you're on, so your first debate with these complicated integrals would be to say, okay, can I logic this out using the chain rule? In this case, we noticed that y equals x squared was just so pretty, it was so close. And what visualizing that u substitution allows us to do is say, oh, if I were to do the chain rule here, what's going to pop out? The 2x. That's almost exactly what I want. If I add the 1/2 here, I perfectly get the cancellation I'm after. So even though this is not a trick that we teach you when you're flipping through the book, it really is the case that if you can, peer into the future with your chain rule expertise, that you can save yourself a lot of advanced calculations. In this case, what I'm hoping you see is that, okay, if I take the integral, or if I take the derivative of this, I'll end up right back where I started. It's a simple application of the chain rule. With one exception. Here's my erase. This is how I got myself in trouble. We don't do calculus with square roots. This won't be 1/2 anymore. It'll look like this.
I'm lost on
So, yeah, I get it, everything.
When you take the integral
Okay, there you go.
But way to integrate
getting ready to put in my evaluation, right? You're right, we still need to evaluate this where
Oh, 0, 0.
0. As you can tell, this is gonna get nice and ugly. Now I'm gonna save myself a little bit of work here.
So is it necessary, sorry,
No.
is it necessary if you do the, if you can do the B1 square?
Hold on. This point, shouldn't we have our X's, or that X in there replaced?
It's waiting to be evaluated.
Oh, okay.
I'm gonna clean it up a little bit before I do evaluate it.
Okay.
So, the first thing I'm gonna do is I'm gonna pull this guy out.
Is there something B1 square?
D y squared, y squared.
You multiply the y with the y. Oh, that's a little more.
Because you don't know what?
Sorry,
No, please.
I'm already at the stuff, it doesn't look fine.
No, it does not. That's why I'm trying to clean it up in some way that it will look not terrible. This is 1/3.
We can pull the 1/3 out in front on the
Uh-huh.
other side, and on the other side of the integral, right?
Yep, it's gonna come all the way out.
All right, good.
3/2. Still gotta evaluate this guy, 0 to 1. Wow. Is equal to 1/3, 0 to 1. Y. Plug in 1. 1 plus. I keep. Oh, maybe that's what you're saying. Square right there. Minus, plug in my 0. Y squared. 3/2. dy. Yes.
Would it be better, just for neatness, would it be a good idea just to times that by blue, or should we just do it like that?
Come on, right here.
Yeah, for that one, and I guess the other one, just make it y plus y cubed to the 3/2 minus y cubed to the 3/2. I just wanna know what's gonna look neater. Theoretically, it should work out.
Let's see. If you multiply the first one there through,
You know what, my question is silly, we shall move on.
I can't visualize what that's gonna look like.
How would you even do that though, if it's two
Yeah.
of power multiplying it through?
Yeah, that's why I can't convince
Because I
myself
mean,
how that would
I
work
could,
out.
I could
Because
see
you
how it
can't
would work
distribute
without
the
that
3/2.
power, but yeah.
Yeah.
It's not-
You can convert, what you would do is, you can do that.
Are you going for three?
I don't think we
Did I forget a 3 somewhere?
Yeah, you can,
Should be
you
X.
can put the Y in there, but you have to
It would have to become y to the,
2/3.
Yep, and then you push it through.
Oh, wait.
That'd be ugly.
Wait, the y, the one that would have to be y to the
Let's not do
2/3.
that.
When you push it in. Think about what happens if you wanna push a y into a 4th power. Think about what this y becomes when it's living in here, it becomes y to the 4th. So this y, if you want it living in here, becomes y to the 2/3.
So 2/3 of.
Okay,
So when you did your U sub, is it safe to say that you did the U sub exactly how it's supposed to be done, but you just ignore the bounds? Basically, because I'm just,
yes,
that's just how.
you can replace the bounds and you get back to this.
But that second, that y squared to the 3/2, couldn't you just write that as a y cubed?
Yeah,
And then just factor in, just make it a y for it, y to the fourth?
Yeah, that's how I do it.
yeah, I'm just not there yet.
Oh,
I just got where I plugged in 0.
oh, okay, never mind.
No, you're fine, right? And that's what ends up happening, like, you guys all see different things, and that's fine. Y, 1 plus y, 3 halves, dy plus 1/3, integral 0 to 1. When we integrate 1 plus y, keep leaving that off, this will be squared, right? I'm going to use the same technique I used before. This will be 1 plus y squared. This goes up a power, 5 halves. I need a 2/5 to get rid of it on the back end. I will also be pulling out another half will come out of there. Yes.
I'm sorry, can you quickly go over again how you, change that, the y times the y squared to 3 half and made it that?
Right here?
Mm-hmm.
Sure. This is y to the first, y to the 2 times 3 halves. 2's cancel. This is y cubed plus 1 more y, y to the fourth.
Where did the 1/2 come from?
This 1/2,
Yeah.
chain rule. If you were going to take the derivative of this, right, you'd bring the 5 halves down. That would get rid of this. You would leave the inside the same. You would take the derivative of this, that's 2y. I don't want 2 y's, I just want 1. Well, the half comes in. Again, if you need to slow this down, you can do this with u substitution. Worried about, this class gets out at 6:50, right? So we're 6:50. Okay. Either way, we don't have, I know this is a difficult integration. I think that this is maybe the hardest one we have to cover today. Here to here. So, minus 1/3. Oh, this is value from 0 to 1. Minus 1/3. Y to the 5th. 1/5. Evaluated from 0 to 1.
You're not missing one?
So, this is equal to, let's see, let's have fun with all these fractions. This cancels out, this is 1/15. 1 plus y, 5 halves, minus, this is again 1/15. Y to the 5th, all evaluated from 0 to 1. Yes.
No, no.
third line up, that's a one plus y squared, right? Supposed to be one plus y squared.
Yep. That's slightly incorrect answer though. The question is where did I mess up? This should be fun.
There should be a test too, but shouldn't.
Is it the,
2 to the power of 5 over 2 minus 2 over 15? Look at the line before that. Nice.
Where are you at? Right here?
Right, no, on the bottom, right there. Because it's minus 1 and minus 1.
Oh. So this would be. Yeah, thank you. Point 2433. He pointed out, I canceled these two out,